Okay, for the next experiment is you will control the PWM signal based on the analog input signal. So like I mentioned you before, um, uh, we have the input from the potentiometer here, right? Will be going to analog input, and then we can control the output of the PWM. Okay, so analog input here is we can get it for voltage analog to digital converter, and the V reference is normally is 5 volt here, and then after that we can get the data, or we call it the digital output from the serial monitor. Okay, and then you write your program here, right? Okay, and then it will print the output from the serial monitor. We will see on that. Okay, and so the result for that second experiment is will be like this one. So V reference in the theoretical is 5 volt, and from the experiment you will measure it. It will be equal to 5 point something, or maybe a 5 volt. This is the V reference, alright, V reference. And then so if we rotate our potentiometer at the 100%, so we will get the serial monitor, alright. It display the ADC value is 1023, and the PWM value is equal to 255, and then from the ADC voltage you also can measure 5 volt, and the experiment is 5.4, and this one you will be some error lah. So this one you need to discuss on your report. And after that, at the same time you will see that the frequency from the oscilloscope display. So this one you can't measure it because of the limitation of oscilloscope and so on, but you can see the output of the LED will be strong. And then after that you try to rotate potentiometer at the 50%, right? For example, this one, you rotate it at the 50%, and you will see that the output is of the serial monitor, the HD value is 512, the PWM is 128, and it will give you the voltage for DC value is 2.5, and the experiment is and so on, so they will give you an error here. Okay, right. So thank you. All right, Assalamualaikum. Very good evening to all of you. So we will continue the experiment 2, all right, for the experiment 1. So the first one is we need to construct the circuit to generate a PWM signal at the different duty cycle. As you can see here, this is the circuit that I have constructed. So you have the multimeter here, and this is the Arduino, and this is the wiring to the LED as the output, and you put the oscilloscope here. Okay, I hope that you can see that. And then the construction of the circuit will be like here. So multimeter we use to measure the average voltage of the PWM output. Then you do like this one, and then you open the Arduino IDE, right, or software. You write a code here. For example, this is the code that I write here. So this is the value that you want to control the PWM. The maximum is 255, that will give you the 100% duty cycle, and the minimum is zero duty cycle. So right now let's choose the 230. Then the output of the PWM pin is pin 9, and you use this analog library in order to generate PWM. And then after you have connect your Arduino to your USB port, then you can choose the COM port, right, at the serial communication, and then you just can upload your program. Now you see that it's uploading your program here, and done uploading, and you will see that this is the result, right? And you see the LED strong will be the brightness will be strong. Okay, and the output, when you write into your output, you see that the value is 230, and then the multimeter, the voltage average like this one, I connect this one is like 4.23. Then the output voltage you can see at the oscilloscope here. Alright, it will show you the duty cycle here and also this frequency here. Okay, so this is the example result. I got it. The frequency for 9.1, duty cycle is 90%. Is shown to this oscilloscope, and the LED is strong. So let's change to the value equal to 10, and the value equal to 10 here. Then you just upload, and you will see that the yeah, the LED brightness will become a little bit lower, and then this is the multimeter output 0.19, and then the frequency now is like a 4%. It's like a 4% here. Okay, 4% is shown here, and then the frequency remains same. This one show that 488 hertz. Okay, and then from the result from here, so you need to draw all the parts here. Okay, so that's it for the experiment 1A. This one for the experiment 2B, which is controlling the PWM based on the analog input signal. So if you like, you can see here, right? So we have the output, which is the LED, the same setup there for the experiment 2A, and then we have the input, which is controlling by the potentiometer, the input for analog signal. All right. So we write we write our according here, and then we will generate the PWM output here. So when we control this potentiometer, you will see that the PWM signal will be controlled. And then what you need to do, you need to write a program, right, in the Arduino IDE here. So it's like this one. Okay, and then when you upload the program, so you upload the program, upload it. Okay, and then you need to open up the serial monitor to see the output. So right now you can see the output for ADC value, which is input is 0, and then PWM value of course is 0. And this one is the experiment setup here. So you will see that the multimeter here, and then this is the potentiometer. They have a certain of angle here, and then the output of the PWM will go through the LED, and this one you can see the pass of PWM. So right now we have set up our value for 230. Okay, and what you need to do is you need to adjust potentiometer at the 100%. So that means 0 degree, you adjust it to 100%. Okay, this is the 100%. So you will see that the output of the LED will be strong enough, and then the PWM and also the ADC value you will get it from the serial monitor. So the maximum one is 1023, and then the PWM is 255. Okay, and then you rotate the potentiometer to 50 degree, like for example 2.5, because the maximum is 5 volt, 2.5 here. So you equal to 360 or 180 here. Okay, so you will see that this is the ADC value and also the PWM value here, and then you record your all the value that you see here, and then from this one you can compute the error. And also with this one you will see the frequency that appear on the oscilloscope, and what is the duty cycle here. Okay, in this case if frequency is 488 and the duty cycle is about 50 percent. Okay, and also you will see the LED brightness here. Okay, so that's it. Thank you.